Hi guys, today we are covering 7.3 similar triangles. You guys will be able to identify similar triangles using the angle-angle similarity postulate and side-angle-side and side-side-side similarity theorems, and you'll be able to solve problems using the properties of similar triangles. So first of all, we have this postulate 7.1, the angle-angle similarity. It says if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So guys, these are kind of close to being like our congruence statements, but instead they are looking for similarity. So the triangles aren't exactly the same size and shape. They're just the same shape, but different sizes. So if you have two pairs of congruent angles, like we have here, angle A and angle F, and angle B and angle G, we are guaranteed that our triangles are similar. Now when we write similarity statements, like when we write congruent statements, the order does matter. We have to make sure these match up. So we're going to use the angle-angle similarity postulate. We're going to determine whether the triangles are similar. If so, we're going to write a similarity statement and explain our reasoning. So on this first one, I noticed that angle B and angle D are congruent, and that's great, but we need to figure out if we have another pair of congruent angles, hence why it's called angle-angle similarity. So what I can do is I can figure out if angle A is 80 or if angle F is 58, all right? Either way you do it, you'll decide if this works or not. So I'm going to go with finding the measure of angle A. So when I add these, I get 100 plus the measure of angle A is 180, which means that the measure of angle A is 80 degrees. So now that I have angle E and angle A congruent to each other, these triangles are similar because of the angle-angle similarity postulate. And I'm going to shorten that to angle-angle sim postulate. You can write similarity if you want to. And then we do need to write our similarity statement. I'm going to say triangle ABC is similar to, we got to make the second one match, EDF. Also, same as our congruent statements, these don't have to be in alphabetical order. Our second one here is not. They have to match, okay? Second question. I notice that these two angles are vertical to each other. So this is the vertical angles theorem. So I know that they are congruent, so I marked them congruent. Ooh, I also notice that I have two parallel lines. So this and this are parallel, which means I can think of this as a transversal, meaning that by alternate interior angles, theorem specifically, these two angles are congruent. So I do have two pairs of congruent angles, which means that these triangles are similar because of the angle-angle similarity postulate. So we can state that these triangles are similar with a similarity statement. So we have triangle QXP. I got to make the second one match. And when I say match, I mean I go from double mark to single mark to no mark. So I got to do that over here. NXM. Okay? Go ahead and pause me. Try this next one. All right, this is like our first one that we did together. We have to figure out if, for instance, A and G are the same since we only know angles B and F are right now. We have to have two pairs, angle-angle similarity. So to figure out what angle A is, I'm going to take 42 plus 52 plus the measure of angle A, not 8A, my bad. That'll give us 180. So we combine like terms, get 94 plus the measure of angle A is equal to 180. We subtract 94 on both sides, and we get the measure of angle A is 86 degrees, which means angle A and angle G are congruent to each other. So we have angle, angle, sim, so these triangles are similar. You can just say yes by angle, angle, sim, and we need to write our similarity statement. So I'm going to do triangle A, B, C is similar to triangle, make them match, G, F, H. All right, the next page, we have two more theorems. These are other ways to tell if triangles are similar to each other. And you might be saying, wait, I thought side, side, side told us congruence, and I thought side, angle, side told us congruence. That's true, just plain old side, side, side does tell you congruence, and side, angle, side tells you congruence. But this is specifically side, side, side similarity. So when you are using this in the future in any proofs, or just talking about things being similar, you have to write side, side, side similarity, or side, side, side sim. These are two very different things, okay? So keep them separated by including the word sim or similarity. So 7.2, side, side, side similarity says, if the corresponding side lengths of two triangles are proportional, then the triangles are similar. So if we check our proportions, we've had a bell ringer like this already, and these are similar to each other, meaning we reduce them and they're the same fractions, or we divide them and they're the same decimals, then the triangles have to be similar. We can also do this idea as well, but only two side lengths if you have a congruent included angle. And then you can write your similarity statement. So this first one here, determine whether the triangles are similar. If so, write a similarity statement, explain your reasoning. We can use either side, side, side sim or side, angle, side sim because these are vertical. Now, I'm just going to use side, side, side sim on this one, and I am going to explain to you how I'm going to do that. So I'm looking at two separate triangles here. I have this triangle, and I have this triangle. What I'm going to do is I'm going to look at my blue triangle, and I'm going to order these numbers from least to greatest. Then I'm going to look at my red triangle, and I'm going to order those numbers from least to greatest. This guarantees that if these reduce to the same thing or are the same decimal, that we have similar triangles. So I'm checking on my calculator right now. These all are the decimal 1.5 when I divide them. So since they are all the same, we can say yes by side, 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 and we have to specifically say similarity. Sorry, spelled it wrong. Similarity, there we go. These triangles are similar. So we need to write our similarity statement. So I'm going to say triangle A, B, C. Now this gets a little tricky because I have not marked out my angle congruences. I can do that if I want to, but I'm just going to think that I'm going across the biggest side, then I'm going to go across the medium side, and then I'm going to go across the smallest side. So I need to match that up over here. So it's going to be triangle D, E, C for my other triangle. Okay, this next one might look a little bit confusing. We actually have two triangles in one. We've got this triangle, And then we've got our overall triangle. I'm actually going to redraw the overall triangle to help us out. Because the overall triangle, we're actually going to have to do some addition. We're going to have to take 15 plus 10 and get 25. And then we're going to have to take 12 plus 18 and get 30. Okay? Now, we don't know anything about that last side length. But what we do know is the fact that this angle is reflexive in the shape that we are given. So those angles, since they are the same, are congruent to each other. So now we can set up proportions here. So even though we only have two sides, we can do the same thing. Within the smaller triangle, we can order the numbers from least to biggest, smallest to biggest, and in the bigger triangle we can do the same thing. Now we've discussed our three options for checking if these are proportional. Reduce your fraction, find a decimal, or cross multiply. And I am going to cross multiply on this one. So when I cross multiply, I end up getting that 300, because 10 times 30 is 300, equals 300, because 25 times 12 is 300. So we are good to go there. So we can say yes. Similar. By, side, angle, side, sim, and you do have to write the word sim or similarity, just like we had to do with side, side, side similarity, because they're different than the congruence ones. And then, let me change color here, we'll write our similarity statement. We have M, N, P, similar to triangle M, R, S. And I did make sure to match these up. Okay? You guys can go ahead and pause me, and then we'll look at the U-try. Okay. I went ahead and wrote on here, for the ratios, pair up the smallest, medium, and largest sides. That's just ordering them smallest to biggest and then putting them in fractions to compare. That's going to be your easiest and best option. So for this U-try, I noticed, like I talked about on the first one, that we could have done and used the vertical angles theorem. We're going to have to do that here because we don't know what these third sides are. So we can't do side, side, side similarity. We can only use side angle, side similarity. Once again, match up your small sides within your two triangles. So my smallest side in the red triangle is 2, and my smallest side in the blue triangle is 6. Then my biggest side in the red triangle is 4, and my biggest side in the blue triangle is 12. You can either reduce, find a decimal, or cross multiply. I'm going to cross multiply again. I feel like this is the easiest one to do when you only have two fractions, because I can quickly see that 24 is equal to 24. So these triangles are similar by side, angle, side, similarity. And we can write our similarity statement. Triangle PRQ, make the second one match up, is similar to triangle SRT. Okay, our next theorem. We've seen theorems like this before. Your reflexive property of similarity works, your symmetric property of similarity works, and your transitive property of similarity works. So we've seen reflexive, symmetric, and transitive before. Reflexive is congruent to itself. Symmetric, there are 2 things, but you can write them in either direction. In transitive, you have 3 things, but they are congruent, all of them. Or I guess, sorry, not congruent, similar, because we're looking at similarity. Okay, so we're going to do some solving here, because these are not as straightforward as congruent problems because we have to use proportions. We have to cross multiply to solve. So it tells us that we have these parallel lines, which means we have alternate interior angles, and then we have the vertical angles here. So by angle, angle, sim, we know these triangles are similar. It doesn't tell us that like straight up, but we can figure this out. It also labels all the rest of these things for us. Now, you might be wondering, how do I set this up if I can't do small, medium, large? Some of these are a little easier than others. For instance, you can mark your congruent angles like I had here, and then you can see how they pair up. So you'll notice that the 4 and the 10 are between the double and the no markings, so they get paired up. And then our algebra is between the single and the double markings, so they get paired up. Now, it's very important, since I put 4 on top, I have to put x plus 3 on since they are in the same triangle. Make sure you do that. Pair them up correctly. Sorry, my computer's being slow. Okay, from here, shouldn't be too bad. You just cross multiply to solve. Now I will have to distribute. So I'll distribute the 4 through and the 10 through. So I get 8x plus 40 equals 10x plus 30. And then I subtract 30 on both sides and subtract 8x on both sides. So I get that x is equal to 5. Now, I boxed that answer, but that's not actually my answer. I didn't read the whole question to you, but it's asking for QR and QT. So QT is this algebra, and QR is this expression, so I need to plug that back in. So QR is 5 plus 3. Getting ahead of myself. So QR is 8. And then QT is 2 times 5 plus 10, or 20. Now remember, these will not be congruent. They are proportional, but they are not congruent to each other. Okay. Go ahead and pause me for a couple minutes. Try this, you try. Alrighty, once again, this is really similar. We're looking for AC only this time, though. We are told that we have parallel sides, so we can find alternate interiors again, just to help us orient ourselves, and we also have vertical angles. So these should help us now set up our proportion. So I notice 11 and 38.5 are between the single and no mark, so I'm going to put 11 over 38.5, and then I'll equal that to x plus 2 is between the no mark and double mark, and 3x plus 8 is between the no mark and double mark. So I'll do x plus 2 over 3x plus 8. These are similar. We have set up our proportion. So now I can cross multiply. Notice the things from the bottom triangle are both on top, and the things from the upper triangle are both on bottom. That's just how I ended up setting it up. If that's confusing to you, you can flip both fractions. It'll get you the same cross multiplication. Notice I use my parentheses really well because I know I need to distribute. So I get 33x plus 88 is equal to 38.5x plus 77. I subtract 77 on both sides. I subtract 33x on both sides. Oops. I get 11 is equal to 5.5x. So when I divide by 5.5 on both sides, I get that x is 2. Once again, though, not my final answer. It wants me to find AC, so I have to plug it back into this one. Remember, they are not congruent anymore, so you can't take a pick. You have to plug it in exactly to what it wants you to solve for. So AC is 14. All right, on the next page, we are going to go straight ahead into example 4, indirect measurement. This is a way that you can use this in real life. So this says, Josh wanted to measure the height of the Sears Tower in Chicago. I believe it's called the Willis Tower now, but same thing. He used a 12-foot light pole and measured its shadow at 1 p.m. The length of the shadow was 2 feet. Then he measured the length of the Sears Tower shadow, and it was 242 feet at the same time. What is the height of the Sears Tower? So we have 2 triangles stacked inside here. These are similar triangles. I have this little triangle with 2 leg lengths. One is 12 and one is 2. And then I have this bigger triangle. I'm trying to find x, and I am given 242. Now, I'm going to put the little triangle information on top. So I have 2 and 12 both on top. So 2 is the shadow length, 12 is the height. So I'm going to match up the shadow length with the building, and the heights together. So this fraction, let me redraw my arrow. This fraction is about the height. This fraction is about the shadow lengths. We talked briefly that there are a bunch of different ways to set up a proportion correctly. There's actually 4 ways to set up every proportion and get the exact same answer. So this is only one option. I like to pair up shadow lengths and heights, like so, okay? Now, when I cross multiply, being glitchy again, I end up with 2x is equal to 2,904. I divide by 2, and x is 1,452 feet. Okay, so while there are 3 other correct ways to set up this proportion, this one way and those other 3 will give us this answer. Take a second, guys. Look up how tall the Willis Tower, Sears Tower in Chicago actually is. Hopefully you discovered that this is a pretty good approximation for it. Using shadow lengths and a known height can actually help you find the height of a much taller thing that you could not easily measure with like a measuring tape. Okay, you can go ahead and try the U-Try, but I'm actually going to stop our video here and we will pick up with the U-Try tomorrow. Bye, guys.